Okay, so we pretty much covered everything that we wanted to know about NPN transistors. Now let's switch to PNP transistors. The good news is that, well, 99% of our discussions are pretty much the same. So we're not going to actually repeat ourselves. I'm just going to tell you what is different from NPN, and then whatever that I don't talk about it is just, it means that it's exactly identical to NPN transistors. Okay, so how do we build PNP transistors? Well, instead of having a sandwich of N and a P and an N, we have a sandwich of P plus N and P, right? Emitters is still highly doped. The base is still in the middle, and the collector is the one on the top. The since and then the movement of charges are basically, before we had movement of electrons going from emitter to the base to the collector. Now we have movement of holes going from the emitter to the collector to the base to the collector, because, well, we're talking about the p-type material at the emitter. Of course, we have these electrons coming from the base, some of them trying to go from the base to the collector because of the forward bias, and some of them, a very small percentage, is actually recombining with the holes that are coming from the emitter. Everything that you know about the current relationship for the NPN transistors still is valid for the PNP transistors, with one little change that you have to remember, and that is basically, instead of VBE, we have VEB, and instead of VCE, we have VEC, right? So why is that? I'm gonna talk about the root cause of it and then come back to these equations in a moment. So remember, we had, like, basically for the NPN, we had the p-type in the middle and the n-type on the sides, right? And then because of that, the diode was the forward bias diode between base and emitter. So this being emitter and this being the base was actually in this direction, right? So base had to actually have a bigger voltage than the emitter. Now, for the PNP, emitter is the p-type and base is the n-type. So my diode is actually in this direction. That's why emitter should have a bigger voltage than the base. And similarly, when I was talking to make this diode in the reverse bias in the NPN, I made sure that collector has a bigger voltage than the base. Now it's actually the other way, right? So this time the diode is actually in this way. To make it in reverse bias, base has to have a bigger voltage than collector, right? So active mode for PNP transistors means that V base emitter should be smaller than 0 and V base collector should be larger than 0. Or better way of saying it, or another way of saying it, is that V emitter base is greater than 0 and V collector base is less than 0. Okay? Either of these are correct. Now, if you look at the way I've shown it here, I've connected emitter to ground, and then the base is connected to a voltage that is, well, pretty much negative, right? Because the positive terminal of this battery is connected to ground. So whatever VBE I apply here results in the base to be a negative voltage. Same with the collector. The collector is also a negative voltage, right? And then it's actually more negative than the base. Okay. Now, but then in reality, what happens is that we don't work with negative voltages. What happens is that I just make sure that my emitter is pretty high. Like it actually has a higher voltage than the base. So this is more realistic kind of way of showing this, that emitter is actually on the top here. By the way, the symbol of the PNP transistor looks like this. So again, the side that has an arrow, the terminal that has an arrow, is called emitter. So that's similar to NPN, but you can see that we put emitter on the top, collector on the bottom, and base in the middle, just to kind of imply that emitter has a bigger voltage than the base and collector. Okay, so basically you could connect here, you could connect base to ground and emitter to the 0.7 to make sure that the transistor is on. Pretty much the opposite of what we had in the NPN, where we connected emitter to ground and made base 0.7. Okay, so this is the reason that we always use VEB because that's the voltage that is positive, right? If I use VBE, that it means that I'm talking about the negative voltage, everything is going to be messed up. So always, so with the PNP transistors, all the equations are valid. So I can still say this, I can still say that IB, this equation, the second one is really telling you IB is IC divided by beta. And this is really telling you that IE is equal to beta plus 1 over beta times IC, or is just equal to beta plus 1 times IB. Okay? And the last one is just basically the same thing with Early effect. Okay? So everything is the same except that whenever you had base emitter, now you have emitter base. Whenever you had collector emitter, for example, for the early voltage effect, now you have emitter collector. Just because emitter is now big, has a higher potential than everything else, right? That's the only difference that you have between PNP and NPN. Here's another circuit that kind of compares NPN and PNP together. So this is the NPN that we had. The direction of current, because the diode is actually from the base to emitter, so the current is coming into the base, going out of the emitter, and the collector current is moving this way. But for the PNP, because holes are actually moving from emitter to collector, so it makes sense that the current is actually going from the emitter to collector, and the diode is actually from emitter to base. That's why the base current is actually going out. So always use this arrow thingy, the arrowhead here, as an indicator of the direction of the current. So the arrow shows the direction of the current in the emitter, and you know that there's a diode here, so the base has to be this way, and then the collector has to be that way because, well, the current is actually going from emitter, the charges are going from the emitter to collector, so the current is from the collector to emitter. So if the emitter current is in this direction, therefore the collector current has to be in this direction. On the other hand, for the PNP, the emitter current is in this direction, therefore the collector current has to be in this direction, and then the arrowhead is actually telling you that the base current should be in this direction. Okay? In terms of finding the operation region, then for the NPN, remember that like basically to be in the active mode, I had to make sure that the base collector junction is in the reverse bias. So that's why base was smaller than collector. For the PNP, base has to be larger than the collector, right? For the edge of saturation, well, it was when the base collector junction goes to equilibrium. Same thing with the PNP. And for the saturation was when basically base collector diode was actually, for the NPN was basically when this diode was forward biased. Again, for the PNP, we have the same thing, that this diode should be forward biased, therefore collector this time has to be greater than base. For the NPN, we had base greater than collector. Okay, so it's all about like knowing that in terms of equations, I told you the only thing that changed was replacing base emitter and collector emitter with emitter base and emitter collector, respectively. In terms of current directions, well, the arrowhead is actually telling us pretty much everything. So for the NPN, the current is coming to the base and it's always from collector to emitter. For the PNP, it's from emitter to collector. So let me actually write these down to make sure that there's no confusion. And the current is actually going out of the base. In terms of the saturation and edge of saturation, and like see what causes saturation for both of them, it's about like the diode at the base collector junction, right? And we want that diode to be always in the reverse bias to be in the active mode. If that diode becomes forward bias, then you're in the saturation. For an NPN, for that diode to be in the forward bias means that VB has to be greater than VC. For a PNP, VC has to be greater than VB. Okay? And for the active mode, of course, the opposite.